This is part 2 of video 1.5c. So we're coming back dealing with our fraction exponents, and now we're going to be looking at slightly more complex questions. And one important thing is to remember fraction rules when you're doing your simplification. So I'm just going to go do a quick reminder of multiplying and adding fractions. So when you're multiplying, remember that you multiply the numerators together, so the top numbers, and then you multiply the denominators together, the bottom numbers. You go across the top and you go across the bottom. So here we have 1 times 5. That's going to give us 5 on the top. We have 4 times 3. That's going to give us 12. Okay. When you're adding or subtracting fractions, you have to make sure you have a common denominator. Okay, so these two numbers on the bottom must be the same. So we need to convert these to be a common denominator. So a common denominator between 4 and 3 is going to be 12. So we have our first fraction, 1 over 4. To be able to get 12 on the bottom, we're going to multiply that by 3. And whatever we do to the bottom, we have to do the top. So we're going to multiply that by 3 as well. Then we have 5 over 3. To get 12 on the bottom, we need to multiply by 4. Whatever we do to the bottom, we do to the top. So we end up with 3 over 12 plus 20 over 12. We know when we're adding fractions or subtracting fractions, the denominator stays the same, and we just have to add up the numbers on the top or subtract. So here we have 3 plus 20, so we have 23 as a final answer. Okay, so now we're going to get into some examples of using the different exponent rules that we learned in previous sections and also incorporating fraction exponents as well. So we're going to start with 6a, where we have 2 to the 1 over 4 and 2 to the 5 over 4. So we see we have the same base and that the bases are being multiplied. So that means we can add our exponents. So that means that we have 2 to the 1 over 4 plus 5 over 4. We're lucky in this question. We have the same denominator already, so we don't need to convert anything. So we're going to end up with something over 4. We're going to add the top. So we have 1 plus 5, so that's going to give us 6 over 4. Now, we're not going to leave it like this because this can be further simplified. So we can divide the top and bottom by 2. Whenever we have fractions, we need to look to see if we can simplify them. So this becomes 2 to the 3 over 2 as our final answer for this question. Next question, B. So here we have 8 to the 5 over 4 times 8 to the negative 1 over 4, and then divided by 8 to the 3 over 4. So these are all the same base, so that means we can add or subtract them all together. We're also lucky again, we have all the same denominator for our fractions. So let's add those together. So we have 5 over 4 for our first exponent. Then these are multiplying, so that means we're going to add, and this one is negative 1 over 4. And then we're going to subtract 3 over 4 because it's on the bottom, so it means it's dividing. So we end up with 8. We know it's going to be over 4. We have 5 minus 1 minus 3. So that's going to give us 1 over 4. Okay. Next one here, we have c to the 2 over 3, and this is subtracting, so we're going to do minus 5 over 6. So in this case, we do not have a common denominator. So we need to convert these so that they're a common denominator. So the easiest thing would be to change this denominator to be a 6, and then we don't have to do anything to this. So to make this into a 6, we're going to multiply this by 2. Whatever we do to the bottom, we have to do the top. So we get c to the 4 over 6 minus 5 over 6. So we get c to the minus 1 over 6. And then we don't want to leave a negative exponent, so that means that we're going to have to flip this base. So this becomes 1 over c to the 1 over 6, like this. Okay. You could also write this final form as 1 over c to the 6, like that. Actually, same with these. If you wanted to, you could write this as root like this. And you could do this one as 2 root 3. Okay? It'll depend on the question if it says you can't have any fraction exponents or not. So you could write them in this form. Whoops. Hey. You can write them in this form as well. All right. Let's look at the next one here. So the first thing we need to do is we need to get rid of our brackets. So this 1/3 is going to multiply the 27. It's going to multiply the x, and it's going to multiply the y. So it goes here, here, and here. So we get 27 to the 1 over 3. We get x. Now, these are whole numbers, so for fractions, it's easier to write them out like this. So I need whole numbers over 1 to the 1/3, and we have y 9 over 1 times 1 over 3. So now I'm going to do that multiplication. I get 27 to the 1 over 3. For my x, I multiply across the top, 6 times 1. I multiply across the bottom, 1 times 3. So I get 6 over 3. And then my y, I'm going to multiply across the top. I get 9 over 3. All right. Next, I can simplify my fractions. So I'm actually going to go down over here next. So I'm going from here down to here. So for my 27, I'll write that as a root. My bottom number is 3, so my index is going to be 3. My top number here is 1, so if I was going to have brackets, it would be a 1 here, but that just leaves it as this, so I don't need to write anything. X. So 6 divided by 3 can simplify, it becomes x to the 2. For my y, 9 over 3 can simplify, it just becomes 3, so it becomes y to the 3. I put this into my calculator to see if I can simplify this further, and I can. It becomes 3 x to the 3 y 2, and that's the final answer for this question. I'm going to do one more example. Here we have big brackets with the 1/2 on the outside. So this 1/2 needs to multiply everything in the brackets. Okay, so it's a lot of fractions. So in this case, one thing you might do is actually simplify inside the brackets first and then do this multiplication. It doesn't actually matter if you simplify first and then multiply by the 1/2, or if you do the 1/2 first and then simplify after, okay? Either one is fine. I think that you want to have to do the least number of fraction exponents that you can. So in this case, I'm going to simplify inside the brackets first. So let's see what I have to work with here. I have 50 divided by 2. So in terms of bases, these are the only whole numbers. This is an m, an n, an m, an n. So 50 divided by 2, I can simplify that right away to be 25. Keep the brackets. Now I have m to the 2, and I'm going to find another m. There's one on the bottom. So because it's on the bottom, that means we're dividing. So we're going to subtract minus 4. We have n to the 4 minus 2. This is all to the 1/2. So we'll deal with that in a little bit. So now we have 25 m to the minus 2 n to the 2 to the 1/2. I'm going to move this to go on the bottom so I can get rid of it. So I can get rid of the negative, 25 n, oh, hold on. There we go. 25 n squared over m squared to the 1/2. So I've simplified as much as I can inside the brackets now. And at this point, I'm going to multiply everything by my 1/2. So it's going to go here, here, here. And if you had just done this step first, that would have also been fine. You didn't have to simplify in the brackets. It just makes it a little bit easier. I'm going to go up over here now. So I have 25 to the 1/2. I have n to the 2 over 1 times 1 over 2. And I have m to the 2 over 1 times 1 over 2. This number on the bottom is going to be in the index of my root. Because it's just a 2, I leave an empty index. Because the number on top is a 1, I don't need to write an exponent. Now I have n to the 2 over 2. I have m to the 2 over 2. So I can further simplify that. I can find the square root of 25. That gives me 5. Here, this 2 divided by 2 becomes just 1. So if we have an exponent of 1, we don't need to write the exponent. So we just get an n. The same thing happens on the bottom. We just get an m. So this is our final answer. So now you are going to go to page 47 and you're going to do number 8, the left only. And that is the end of section 1.5.